Welcome to Dr. Raz, the Baking Chemist. So today is all about impure ores, copper for jet engines or jets. How do you extract tons of copper? Yes, and believe it or not, it is an AS, a year 1 chemistry exam question. Stick around, it's interesting. Okay, so a passenger jet contains 4,050 kilograms of copper wiring. So immediately I'm thinking it's in kilograms. Okay, might have to change that to grams at some point. A rock sample contains 1.25% of CuFeS2 copper iron sulfide by mass. Calculate the mass in tons. Oops, there's another thing, in tons, some more conversion going on, of rock needed. So it's a rock that we need to produce enough copper wire for a passenger jet. And it's a 4 mark. So the first thing I'm thinking, we need copper, and of course in here there is copper, right? And so what I'm thinking is, if I need copper, then I need this, and this is obviously in the rock sample. Now what I realize is that for every one molecule of this, there's one atom of copper. So if I need sort of 4,050 kilograms of copper, if I turn that into moles, that's the moles of this that I will need, because for every one of those there's one copper. Okay, so, and of course I can't really use kilogram masses, because copper mass is different to this molecule mass, so I can't really start correlating masses. I've got to change that to moles. Okay, so let's change that to moles and let's see where we go from there. Moles of copper that's needed is number of moles equals mass divided by mR. You should know that, or AR. Come on, 4,050 kilograms. Hold on. Okay, I'm not going to do that and say, oh, that divided by AR, because we know that in that formula it's actually in grams. So I'm going to have to multiply that by 1,000 to change the kilograms to grams, and then divide that by the AR of copper, and the AR of copper is 63.5. and what you need, obviously you're going to have periodic table, that's where this comes from, and what that gives you is 63779.5, and I'm going to change that to, look, that's 6 sig fig. Yeah, in the question nowhere is it giving you 6 sig fig, so I'm going to change that, round it up. Oops, 780. Okay, oh, not grams, moles. Okay, moles. So that is moles. So 63780 moles. Right. What that means is that I need 63,780 moles of copper. Now, I know that for every 1 mole of that, I get 1 mole of copper. So therefore, I need 63,780 moles of that. So because copper, so 1 mole of copper Fe, so iron sulfide, CuFeS2, 1 mole of that gives you 1 mole of copper. So therefore I need 63780 moles of CuFeS2, that molecule. Okay, so I need that many moles of Cu. Now the problem we have is, if I actually have, let's say, I have an ore. If I take that ore, not all of it is CuFeS2. Only part of it is CuFeS2, and actually just 1.25% of it, because that's what the question is telling you. So if I take a ton of this, I'm only going to get 1.25% of that is going to be actually copper. Yeah, or that molecule, which will give me copper. So you got to think, okay, the way to do this is, a simple way to do this is find out how much of the ore do you need for 1%, and then multiply by 100. Right? But before you do that, you got to change the moles. Because we're talking about masses here, you got to change that moles of that now back to mass of that. Yeah, so you changed the mass of copper into moles of copper, you related it with that CuFeS2, you said, okay, this is the number of moles, but now because you need mass of the ore, you need to change that from moles to mass of that. And so let's do that first. So change that to mass. So the mass of that is, well, using the same equation, so mass of CuFeS2 mass equals Mr. Moles, right? So Mr. Moles, so that means MR of what? MR of that now. Yeah, and the MR of that, again, from the periodic table, you can actually have a look, but the MR of that is 183.5 multiplied by moles. Okay, and that's 63780. And that gives you, wow, a big number. Right, so that gives you, and 11703. I know you're probably telling me off, oh, you're supposed to be a scientist, aren't you supposed to be using, standard form and what? Yeah, you're absolutely right, I am supposed to be using standard form. Now, again, in keeping sig fig in mind, I know this is not the final answer, so I can have a little bit extra, not a problem. Fine, I'll do that, and then I'll say times 10 to the what? So that's 1, 2, 3, 4, 5, 6, 7. So 10 to the 7. Okay, I'm going that way, so it's 10 to the 7. 7 what? 10 to the 7 grams. Okay, I actually don't need 5 sig fig there, but you know what? It's not the final answer, I don't mind. Okay, I'll continue as I am. I'll do the appropriate sig fig at the end. Okay, okay, so that's how many grams of this I need. Now, going back to what I said earlier, I can't just simply take that many grams of the ore, because in that ore then I'm going to get less than what I need. Okay, so what I'm going to do now is, as I said earlier, work out how much. So if I take ore, right, this ore, and if I take this much ore, the rock, okay, so if I take 1.1704, you can still see it, times 10 to the 7 grams of the ore, that will only give me 1.25% of that. So I want to know, well, how much? So it's better to actually work out how much of the ore, the rock, will give me 1%, and then multiply 100, as I said earlier. So what I'm going to do is I'm going to take that many grams, and let's assume, okay, that much grams of ore I've got, divided by 1.25%, because that will give me the mass of the rock that I need to give me 1% of the CuFeS2. Okay, and so that will give me, that means if I take that much grams of the rock, okay, it will only give me 9363200 grams of what? Oops, of CuFeS2. Can you see? So that divided by, so that's how much CuFeS2 I need. So that's how much of this I need. But each rock sample, the rock sample is only 1.25% pure. So what you do is you take that mass, the total mass of CuFeS2 that you need, you divide it by 1.25%, and that will only give you the 1% of what you need. All right, so that will only give you 1% of what you need. And of course, what is that 1%? That is 936200 grams. But then what you say is, okay, well, I don't need 1%, I need 100%. So you need to multiply that by 100. So that means you need 320000 grams of the whole rock to give you this many grams of the actual CuFeS2. Go back on this video and make sure you understand that. Okay, this is where the students, well, I'll mention that later, but this is, a sticking point for a lot of students. Yeah. Okay, so now obviously the answer isn't that. The answer is we're not finished, because it says calculate the mass in tons of rock needed to produce enough copper. Yeah. So what we need is change that into tons, and it's a simple. First of all, you need to change. I mean, they've given you the conversion units from kilograms to tons, but you need to change that from grams to kilograms. So that will equal, so I'm going to try and move this up, so that will equal 93632, so and 0 kilograms, and of course then into tons you need to divide by 1,000 again, because 1,000 kilograms equals 1 ton, and that equals 936 tons. Okay, so that means you need 936 tons of the rock to actually give you that many grams of the CuFeS2, because that many grams will convert into that many kilograms of copper. All right. So this is one of those questions. Students did find it difficult. They didn't know exactly how to convert from one to the other and how to relate this 1.25% of the rock. So I think most of them, a lot of them actually did change the copper into moles. Yeah, so they got that mark. In fact, let's talk about marks. So the marks are simple. You convert that into moles. So that's 1 mark. Okay, and then of course what you did was, you changed. You didn't have to say this, that 1 mole of copper FeS2 is equal to 1 mole of copper, because you can see that. But then what you do is you say, okay, well, that if I need that many moles, the mass of CuFeS2 that you need is blah 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 blah, and that will be a second mark. Okay, and then the third mark will be realizing that it's only 1.25%. The rock is only 1.25%, so you need to do that. You can do this and this step in one go, so you can do that divided by that times by 100, or do it in 2 steps like I did, and that would be a third sort of mark. And the fourth mark is actually getting the right conversion to tons, which is that. Okay, so that would be the fourth mark. It's only a 4-mark question, but it was a sort of a not well written question. And yes, it is a year 1. It's a physical chemistry, obviously, year 1 exam question, and obviously year 2s will need it as well. All right, and they'd love these kind of questions where they put the principle that they'll test you in the settings that you're not familiar with, just to see if they can confuse you. All right, okay, well, thank you very much. I hope that helped. Leave any comments below if there's something that's still not clear. Leave any comments below, please, and any other suggestions, as usual, are always welcome. And I'll see you next Wednesday. Bye.